Hello, everyone. My name is Sergey. I work for Meta. Well, until yesterday evening, I wasn't even sure that's still the case. We had mass layoffs yesterday, but we are still here, you know. I'm going to talk about a very esoteric feature. So it's Ycbcr samplers combined with Bindless Vulkan. Who knows what Ycbcr samplers are in Vulkan? Good. Who used them at least once? Okay. Who knows what bindless rendering is? More hands, actually. Okay. Let's try to combine them together. I will be just doing a quick primer on what the Ycbcr samplers are, what are Vulkan immutable samplers, and what is bindless, and how to combine them. So the last part is really short, and that's kind of like the main question of today's talk. And I guess if we're having this question today, the answer, how to combine, is it possible to combine bindless Ycbcr samplers with bindless Vulkan and descriptor and indexing? The answer is yes. Otherwise, we wouldn't have this talk. But let's go step by step. Thank you. So what are Ycbcr samplers? It's a niche and complicated feature, and it was introduced as an KHR extension back in the days. And now it is a part of Vulkan 1.1. Essentially, it provides a way to process inputs from video decoders and cameras and automatically convert them to RGB using images in multiple planes and using the data format which is native to the video decoders and cameras, which is usually a YUV format where the luminance and color information are separate and in separate image planes. And Vulkan provides a way to do this automatically. So essentially what's happening, we have our shaders, and the shaders pretty much look exactly the same from Jelly Cell side at least. And we go through some elaborate setup process to tell the Vulkan implementation how to handle our textures, and the driver will generate all necessary code into the shaders, I say, to sample from separate image planes and convert that to RGB. So that's kind of like a brief glimpse how it works. Ycbcr samplers are quite elaborate because they require multiple objects to come together. So before we can create actually a pipeline for sampling YUV images, we have to create a special conversion object. As you can see, there is a create infrastructure, and there is plenty of parameters we had to set up before we create one. Pretty much it's a lot of different options and modes here, and they all support different camera and video decoders formats that are available. So we can use different color models, different conversion ranges, Swizzling modes, interpolation modes like this chroma, subsampling, chroma offsets, and so on and so forth. So it all will start making sense if you are familiar with video decoding, and then every single parameter will resonate with part of your video decoding pipeline. Okay, we created this conversion object. Then we have to create a sampler. So we create a normal Vulkan sampler, and we provide this pnext pointer to chain together the conversion info object that we created earlier. And they are per format. We have to specify the specific YUV format, and can be different ones like NV12, NV21, and plethora of those. And we combine these two things together. So again, let's dwell a little bit on this one. So we create a sampler object, which essentially embodies another conversion object. So we have like a pairs of different objects working together. It's just create kind of combinatorial explosion in some cases if we have to support multiple decoding options and multiple YUV formats. Then we have to create VK image view using the same conversion object as a pnext pointer. So again, we already have two entities, the conversion object and the sampler. Now we add the third one. It's VK image view. It just adds up to the combinatorial explosion. An easy way to manage this is to create a hash table, which is indexed by, in the simplest case, like YUV format, and in a more complicated realistic case, by a structure which describe all the conversion parameters of the YUV conversion object, Ycbcr conversion object. And last but not least, so we want to create a rendering pipeline. And the trick here is, as I mentioned earlier, we want to allow the Vulkan implementation and the Vulkan driver to actually generate the code for us, which will sample YUV information from the textures. And to do this upfront, we want to specify these samplers at the graphics pipeline creation stage and descriptor set layout creation stage, actually. And Vulkan has a feature called immutable samplers. So that's when the samplers are actually embedded into the descriptor set layout. We can specify those. And here we can provide this information, allowing the Vulkan driver to know exactly which formats, YUV formats, we want to convert. And at this point, we actually can give the driver enough information to create the shader instructions to do it for us. So it knows the texture format, the sampler objects, and descriptor set layout. And that's enough information to generate the code at the pipeline creation stage. So far, everything was kind of like pretty much static in the sense that we have to provide a lot of information upfront before we can create our descriptor set layout and pipelines. But let's switch to the second part of the problem, so the bindless and what that means. So bindless is quite the opposite to the static thing. So it eliminates the necessity to bind resources and textures, buffers, and samplers. And in the first presentation today, actually, it was mentioned that there is a world where buffers are replaced with device addresses. We've been living in this world in the past 3 years already. Actually, who saw my presentation on SIGGRAPH last year? Oh, that's nice. It's nice. Yeah, we'll talk about that in the end. So how to combine these two things, bindless and immutable samplers. Let's first think how we usually do bindless in GLSL. So we declare an array of textures, texture2D. We can declare an array of samplers. Those two arrays contain all of our textures, all of our samplers, and we can index them using some non-uniform indices, just integer values. Can we do the same thing with combined image samplers for YUV? Like declare this K-sampler YUV array, call it sampler2D for combined image samplers, and just use the same non-uniform index to access this array. Well, you can do that, absolutely, but it will not work. The reason for this is that at this point, there is no code generated in the shader which will actually convert separate image planes to the RGB form. The driver doesn't have enough information to do that. But actually, that was my very first attempt to solve this, just doing this, right? We can use the texture ID, which is coming from push constants, to access this K-sampler YUV. It produces results. It doesn't trigger any validation errors, and it doesn't work. But with this just very, very small change, we can solve this. Instead of just passing the value as push constants, we can provide a specialization constant, which is obviously available at compile time. And we can use our bindless identifier at compile time, at the shader compile time. sorry, not the shader compile time, at the pipeline creation stage, we provide this specialization constant. And at this point, we essentially specialize the shader with this constant to fetch from the array. It was an interesting backstory how this was found. So I was debugging the previous case where I used just a push constant value, and it wasn't working without any kind of signs of errors and anything. And I decided to replace the push constants values with hard-coded integer IDs. So I just was looking into the debugger, saying like, this is the texture number 2, and this is the texture number 4. And I just hard-coded those values into the shader, and it just magically started to work. And I thinking, aha, now the driver knows that what can be done about that. Well, push constants, specialization constant. And this actually answers the main question of the presentation, how to do that. And I guess if you ever try to combine bindless rendering with YUV samplers, this approach will save you at least a couple of days of debugging and work. All this is open source, so we have a repository with MIT license, which implements Bindless Vulkan, and which is doing this video decoding and some demos how to do that. Just very clean API. Those who saw my presentation at SIGGRAPH know exactly what I'm talking about. So we are making a very experimental wrapper on top of Vulkan, making it fully bindless, and this is the world where buffers became device addresses. There are no buffers there, they're just device addresses. You can download that on GitHub. This is based on Facebook IAGL. Questions, please?
So I think the simplest and dumbest question is why. Not understanding the implementation details on how different samplers are implemented. Right. It doesn't immediately make sense to me why one particular kind of color format just magically doesn't work with push constants, why I can't feed that data in. Perhaps you'd like to answer.
Yeah. There's a current working group spec issue about this. The issue is some hardwares need to do essentially a lookup table, and so they have to have it at compile time. They have to know which sampler Ycbcr sampler you're going to construct. Ycbcr samplers are also immutable, so you can't update them. And so that's where I was kind of waiting for the answer with the spec constant's a very clever way to do it. So that's kind of the issue.
So many, many years ago, one of my very, very first paying gigs was actually to fix YUV decode in a shader for an OpenGL video application. And this was 15 years ago, basically. And my question is, as a developer who, let's say, can actually, read what YUV format I'm using and can't implement, let's say, at least the separate planar format myself using free images and some shader code, what's actually the benefit of having the implementation do that for me with an immutable sampler? Because as I understand, the whole reason why your example broke with non-specialization constants is because the driver is doing the exact same thing I was doing 15 years ago, but for me. Is there like a battery life advantage? Are there actual hardware YUV samplers in the GPUs? What's the story there?
Well, the short answer is obviously just to offload all this kind of like mind problems and issues to the driver vendors, to allow the driver vendors actually to generate the most optimal way to do this from their point of view, because we don't want to hand optimize for different platforms. We just want to use this shared functionality, which Vulkan provides. And another option is that in real life, actually, it turns out that we have multiple formats to support. It's, let's say, more than 3. Which again creates combinatorial explosion. So we have to maintain a plethora of shaders, 3, 4 different formats, somehow switch between them. So we just can generate shader permutations ourselves. And it just creates a burden of support for all these shaders. And if we add support in multiple platforms, adding workarounds for multiple platforms, it just quickly becomes unmanageable and out of hand. That was an attempt to do that. Use the Vulkan 1.1 core feature to solve this problem like once and for all, let's say.
Also, yes, there is hardware that has YUV sampling that is better than just binding free textures. Not all hardware does, but some hardware does, and you want to be able to take advantage of that.
Thank you. Anyone else?
So in your solution, you have to create many pipelines, right? So with different specialization constants. So did you consider having just one single pipeline with just one sampler and then binding one texture and then running the pipeline, then binding another texture and another pipeline? Was it okay for your solution?
We tried basically as soon as you switch to some different texture, it doesn't work. So it breaks again. So it like requires really this combined image samplers to be immutable samplers at the pipeline creation stage. So if we don't use immutable samplers, it really doesn't work for whatever reason. So we were not able to find another way to do that. So yes, we have to create pipelines essentially per format and per texture.
Okay,
And
because
if you check the source code, really kind of there is a kind of exhaustive example how to do this with multiple images in multiple formats. And from the kind of code writer point of view, I believe it looks pretty neat. Check it out.
okay. Yeah, because I think, yeah, you still can have the immutable sampler, but then you bind another image and then you record many commands with the same pipeline object. But okay, maybe I'm missing something. Yeah.
Just kind of to follow up on the previous question, I think sometimes when what you call dynamic but work group uniform indexing does not work, you can just hack it together. So just because I haven't seen the code obviously yet, but did you consider using a switch table and just hard code a lot of samplers? Because as far as I'm concerned, that should work with a push constant, with a UBO, anything like that. If you have like a massive switch dispatcher, which says, well, what sampler do you want? And you have numbers, let's say between 0 and 20. And then you've got 20 different samplers and it's all hard coded. And I wonder if you tried that and if there were like big performance shortfalls because of that.
We haven't tried that, but I will have like an opposite question. If this already works with specialization constant, why would we bother inventing something more complicated with this switch block?
To address the use case of the person who asked the question before me, which is to, I want different samplers. How can I do this without rebinding my pipeline or having different pipelines for different?
We haven't tried yet, and just that our solution is just to rebind the pipelines and create different pipelines for different input YUV images. Anyone else?
So I've been doing YUV color format changes for a while now. Would you say that the YUV samplers are stable enough to handle enough of the industry video formats out there? Or do you feel that it's still got some ways to go to add different video color formats and types of YUV?
That's a super good question, actually. Well, the answer is depends. So for example, we are building for MetaQuest devices. And we know our platform, we know our drivers, everything is stable. And the answer is yes, it is safe and stable and nice and just powers some like kind of internal implementations to fetch video and camera. Works out of the box. But if we target like Android in the wild, let's say that's the whole Safari park of different Android devices, that might be an issue. And I would say, like from my experience, it can end up with creating kind of a list of incompatible devices and a bunch of workarounds. So just profile your results and test on actual devices. But if you know your hardware, if you ship for some specific devices, why not? It works awesome, especially when working with a closed ecosystem like MetaQuest.
Thank you.
Anyone else? I see no more hands, but I'm not done yet. So you see there is like one more slide there. Just there was no question about that. The commercial announcement. So on Thursday, February 14th, our book going to be released. And if you use this QR code, you can get 20% off. There is a number of discounts available. And if you know the first book, it's about like going from one triangle to quite interesting GLTF EBR rendering step by step in Vulkan. And Thursday, February 14th. Thank you all very much.